How do you achieve idempotency in microservices? Imagine sending the same request twice and getting the same result both times without causing any issues. That's what idempotency is all about in microservices. It's a way to make sure that no matter how many times a client repeats an action, the system stays consistent. This is super important because microservices often communicate over networks that can be unreliable. If a request gets lost or times out, the client might retry, and the system needs to handle that smoothly. One of the best ways to achieve this is by using unique request identifiers, often called idempotency keys. When a client makes a request, it includes this key. The service then checks if it has already processed a request with that key. If it has, it simply returns the previous result. This stops duplicate actions, like charging a credit card twice or creating multiple accounts. Designing idempotent operations is also key. For example, updating a user's email address with the same email multiple times should not change anything after the first update. Using HTTP methods correctly helps too. For example, GET requests are naturally idempotent because they only retrieve data. PUT requests are also idempotent because they update resources with the same data. On the other hand, POST requests are not idempotent by default, so extra care is needed to make them safe for retries. In event-driven microservices, messages can be delivered more than once. To handle this, consumers should track processed message IDs. If they see the same message again, they can ignore it or confirm it has already been handled. This prevents duplicate processing and keeps data accurate. Databases also play a role. Using unique constraints can stop duplicate entries from being created. Transactions help by making sure that a series of database operations either all succeed or all fail together. For example, inserting a record with a unique key will fail if the record already exists, maintaining data integrity. Retries are common in microservices because of network issues. To avoid problems, systems should be designed so retries do not cause duplicate effects. This is where idempotency shines, making systems more reliable and easier to maintain. Many frameworks and API gateways support idempotency features out of the box. They can handle idempotency keys and retries, simplifying the process. For example, when a user submits a payment request, they include an idempotency key. If the request times out and they retry, the service checks if that key was already processed. If it was, it just returns the previous result, preventing double charges. In summary, making microservices idempotent involves careful API design, using unique request identifiers, handling duplicate messages safely, and leveraging database features. This approach keeps systems consistent, reliable, and ready to handle retries and failures smoothly.